Okay, so let's look at this next example. Here we are looking at if cosine of t is equal to -8/17, and they're giving you restrictions on what t can be. So let's talk about that for a second. They're saying t is in between 0 and pi. So a lot of times I'd like to do a quick sketch and remind myself that t will be somewhere in between here. Now, because cosine is negative, I have a better idea that we're most likely in quadrant 2. Otherwise, if cosine was positive, we would be in quadrant 1. So it already kind of tells us where we're at. It's really nice. And the spirit of this problem, I believe they want us to use the unit circle approach. So if they're giving us a value of cosine t, and they want us to find the values of the other 5 trig functions, you can use the Pythagorean identities. And I always like to start off with my favorite, sine square plus cosine square is equal to 1. And what we can do is you can kind of create a bit of an equation here. So as far as the Pythagorean identity goes, I have sine squared t plus cosine squared t equals 1. And we can replace cosine t into this equation, our identity. So I have sine square of t plus cosine square of t. Now kind of remember, I'll write it like this for a second. Cosine square of t is the same thing as cosine t square. Sometimes it's easier to write with notation, but this helps us with plugging in what cosine t should be. And we have cosine t is now going to be -8/17. So we have that equaling 1. Now do yourselves a favor. We can simplify just a little bit. We have sine squared t plus, if we square a negative, we'll get a positive. 8 squared is 64. 17 squared, you may need to get that calculator out, as I do. I'm getting 289. And that's equal to 1. So now we have everything in terms of one trig function. So we treat it like a nice mini quadratic equation in a sense. So what we can do is subtract 64/289 from both sides. So this will leave me with sine squared t equals, now if we're saying 1 minus 64/289, you can definitely use your calculator, but we would need a common denominator. So I'd have to multiply by 289/289. So that would leave me with 289 minus 64 all over 289. And that will leave us with 225/289. So the number's getting a little bit larger. I definitely make use of my calculator. And we could have done this without having to do this by hand, but might as well review some fraction math with you. So we're almost there. Remember, we have to find the values of the other 5 trig functions. So at this point, this is kind of giving us an idea of what sine of t will be. If I'm going to solve for sine of t, I need to take the square root of both sides. And a little bit of algebra, we do have plus or minus, but we'll talk about this in a second. This is going to leave us with sine of t equals plus or minus. And now hopefully we have ourselves some perfect squares, so we can use our calculator. If you have the square root of 225, that looks kind of familiar. That should be 15. And then the square root of 289, I believe we found that earlier, that's 17. Now, to be just a little bit more precise, remember, we are in the quadrants 1 and 2 because we're in between 0 and pi. So when you're looking at what the sign should be, and I say the sign of sine, we know that when we're in quadrants 1 or quadrant 2, the sign is positive. So right away, we can take the positive version. So this gives us sine of t equaling 15 over 17. Now, there's a couple of ways to go. Sometimes at this point, if I already know what sine of t is and what cosine of t is, I can use the quotient identities to figure out tangent and cotangent. And I can use the reciprocal identities to figure out secant and cosecant. So let's take a look at that. Let's just go moving over. I'm going to use the quotient identities to figure out what tangent is. So I can say, let's do this a different color. Tangent of t is equal to sine of t over cosine t. Now keep in mind, we want to replace this. We do have the sine of t, which was 15 over 17. And cosine of t is negative 8 over 17. So we still have tangent of t that we're looking for. And now we've got ourselves a complex fraction. So remember, we're looking at ways to simplify this. There are some shortcuts, but we technically have ourselves a division bar right here. And remember, we do have a positive fraction divided by a negative fraction. So in the end, we will have a negative answer. And if you'd like to, you could rewrite this as numerator 15 over 17 divided by 8 over 17. And then with a little bit of math going on, remember that when we're dividing, it's the same thing as multiplying by the reciprocal. So we can change the division sign to multiplication and take the reciprocal. And remember, we're still finding what tangent of t is. So I'm almost there. I think I'm going to move up just a little bit so that you have the view here. So let's simplify this. We have tangent of t. We do have a negative, and we do see that the 17s divide out. So we do have negative 15 over 8. So we have sine, cosine, and tangent. If you want to, straight from tangent, you can use the fact that cotangent of t is cosine of t over sine of t, or you can use the reciprocal identities to also calculate this. So let's move over. I kind of like to use all these fundamental identities at once. We'll get used to it because you see this a lot in trigonometry and calculus. So what I like to do is if I can use my reciprocal identities, maybe that'll be kind of a nice way. And pretty much what we are looking at, if we know that we're looking for cosecant of t, that's equal to 1 over sine of t. And so we already realized that we had sine of t to be 15 over 17. And what the reciprocal identity really does is when you're dividing by a fraction, you're actually going through the fraction math and you're multiplying by the reciprocal. You can utilize some shortcuts that you've learned in your past. And what it really does is it takes the reverse, or I should say the inverse in a sense. I'm using that very loosely here. You basically switch the denominator and numerator place. So cosecant of t, we see it's the reciprocal of sine of t. We have 17 over 15. Now similarly, we can do that with secant of t. And I'll move over to the side just a little bit. secant of t is the same thing as 1 over cosine t. And if you realize that that is really just saying take the reciprocal of cosine, you could go back and say, well, what was cosine of t? It was negative 8 over 17. So what we can just say, I'll write it out just in case. What this does is it inverts the 8 over 17 to be 17 over 8, and don't forget the negative sign. So we're looking for the values of all the trig functions right now as far as what we have circled. We have cosine, sine, tangent, cosecant, and secant. Last thing, we could look at cotangent and use the same idea. If you want to look at cotangent, you can be careful because it says cotangent of t. That is the reciprocal of tangent. So it's 1 over tangent, or we can take the inverse. What we said, cotangent is cosine t over sine of t. So I'll use reciprocal since I already have tangent of t calculated. And so that's going to leave me with 1 over tangent t takes the reciprocal, so cotangent of t gives us 8 over 15, and don't forget the negative sign. So we have now figured out all of the 5 trig functions. This is one way to go. They kind of talk about this utilizing the unit, circle, and a lot of the identities. In the next example, I'll do this one more time and I'll give you another technique to use as well. So you can kind of take your choice. I'll see you then.